Okay. So now let's get to a slightly more difficult problem. We're given once more a set with n elements. We already know how many subsets that set has, but now we will be interested in subsets that have exactly k elements in them. So we start with our big set that has n elements, and we want to construct a subset that has k elements. Out of those n, I'm going to choose k and put them in there. In how many ways can I do this? More concrete way of thinking about this problem, you have n people in some group, and you want to form a committee by picking people from that group, and you want to form a committee with k people, where k is a given number. For example, a 5-person committee. How many 5-person committees are possible if you're starting with 100 people? So that's what we want to count. How many k-element subsets are there? We don't yet know the answer, but let's give a name to it. And the name is going to be this particular symbol, which we read as n choose k. Out of n elements, we want to choose k of them. In how many ways can I pick k out of these people and put them in a particular order? So how many possible ordered lists can I make that consist of k people? By ordered, I mean that we take those k people and we say this is the first person in the committee, that's the second person in the committee, that's the third person in the committee, and so on. So in how many ways can we do this? Out of these n, we want to choose just k of them and put them in slots, one after the other. So this is pretty much like the license plate problem we solved just a little before earlier. So we have n choices for who we put as the top person in the committee. We can pick anyone and have them be the first person. Then I'm going to choose the second person in the committee. I've used up one person, so I'm going to have n-1 choices here. And now at this stage, I've used up 2 people, so I have n-2 choices here. And this keeps going on. Well, what is going to be the last number? Is it n-k? Well, not really. I'm starting subtracting numbers after the second one. So by the end, I will have subtracted k-1. So that's how many choices I will have for the last person. So this is the number of ways. The product of these numbers there gives me the number of ways that I can create ordered lists consisting of k people out of the n that we started with. Now you can do a little bit of algebra and check that this expression here is the same as that expression. Why is this? This factorial has all the products from 1 up to n. This factorial has all the products from 1 up to n-k. So you get cancellations. And what's left is all the products starting from the next number after here, which is this particular number. So the number of possible ways of creating such ordered lists is n factorial divided by n-k factorial. Now, a different way that I could make an ordered list. Instead of picking the people one at a time, I could first choose my k people who are going to be in the committee, and then put them in order and tell them, out of these k, you're the first, you're the second, you're the third. Starting with these k people, in how many ways can I order them? That's the number of permutations. Starting with k objects, starting with a set with k objects, in how many ways can I put them in a specific order? How many specific orders are there? That's basically the question. In how many ways can I permute these k people and arrange them? So the number of ways that you can do this step is k factorial. So in how many ways can I start with a set with n elements, go through this process, and end up with a sorted list with k elements? By the rule that when we have stages, the total number of stages is how many choices we had in the first stage times how many choices we had in the second stage. The way that the number of ways that this process can happen is this times that. This is a different way that that process could happen, and the number of possible ways is this number. No matter which way we carry out that process, in the end, we have the possible ways of arranging k people out of the n that we started with. So the final answer that we get when we count should be either this or this times that. Both are equally valid ways of counting, so both should give us the same answer. So we get this equality here.